Hello and welcome to the first episode of my CAD for 3D printing series. So what we're going to do today is, I saw this really neat product here. It's called a V-drill guide, and it lets you drill corners into like square stock, it lets you drill into round stock like this, and it's got various different, drill bit sizes. So I'm just going to kind of go through my design philosophy on this. Usually when I'm working with stuff that I'm going to be drilling through or using around power tools with 3D printing, so like any kind of guide or jig, I want those to be very simple and easy to replace. The main reason is because no one drills perfectly straight holes with like a hand drill. And so you're inevitably going to miss, you're going to scrape bits off the side, maybe your 3D print's a little small due to like heating and cooling and causing it to shrink or swell a little bit, and it's going to wear down the inside of these holes. And that's probably either going to A, just destroy your tool, your 3D printed tool, or B, just not provide like an accurate hole. So what we're going to do is we're going to make it so that we can customize the size of this hole. And this is going to touch on a couple of key aspects of FreeCAD. FreeCAD's the software that I use for most of this stuff. So what we're going to do is we're going to start real simple with part design. So you can see up here, I can select the different workbenches, and I'm going to go to part design. So part design lets you kind of build out a single part. First step, anytime I'm using part design, you can see that it's a completely empty tree here. I'm going to hit create body. This creates a new object, and this is what we're going to be doing all of our work in. So I'm going to start by making a body. And I'm going to start by making a sketch. So the way that I'm personally going to do this is I'm going to start by extruding something up. So I'm just going to start here. You can see that when I create this line at the origin, and I start to drag it around, you can see that it has a couple of like things pop up near my mouse. So you can see that vertical line. That means that it's going to constrain this line to be vertical. And that dot means that dot on the curve means it's going to be constrained to have the endpoint be on the line that I'm currently over. In this case, it's the y-axis. So I'm going to do that. I'm going to pull one out to the horizontal. I'm going to pull one out to the vertical again. And then I'm going to pull one here, here, and one here. Now the important part that I want to stress about this part is that you want to make sure that everything here is connected. So if you notice when I was doing that, I would wait until this kind of circle with 4 little lines around it shows up before I start dragging out my line. This means that it will join the endpoints. So let me show you what it looks like if I don't join one of the endpoints. So if I don't, here, let me do that again for you, a little bit slower. So I join the endpoint here, and let's say I just kind of eyeball it, and I put it close-ish, right? A lot of the times when it's super, if you're going fast and you miss this, it's going to be something that looks very similar, like that. And one of the ways you can test this is you can just kind of move parts around it. Oh look, these two are disconnected, right? These are all connected here, but I've got 2 points where it's not connected. Now, how would I go about connecting these two? I'm going to hit Control and select the 2 points that I want to connect. I'm going to go over here to the constraints, and I'm going to click on the create a coincident constraint. I'm going to click that, and those 2 points are now going to be joined. These 2 lines will move around. I'll do the same here, but I'll use the keyboard shortcut C. Perfect. Now, what we have here is we just have kind of an unconstrained, lots of degrees of freedom. It's a mess. There's no units. So I'm going to start by using some of these constraints to make this look more like that guide that we were doing. So, that we wanted to have. So first off, I'm going to select these 2. vertical ones, and I'm going to hit this one here. This is the equality constraint. This is great for when you want things to be of equal lengths. As you can see, when I move this point up, the other one also moves up. So what we're going to do now is we're going to use another equality constraint on these two here. Those are also going to be equal. The reason I've got this cut out in the middle is because you can see this picture. It allows me to have slight imperfections in how this is manufactured. Because if I have like a perfect corner here, and say it rounds a little bit, if I take a piece of square stock and I shove it into that corner real hard, it's going to run into the slight like fillet or chamfer on the inside, and I won't be able to get it square. So this is actually a really intelligently designed tool here. So we're gonna follow that original design inspiration, and we're gonna go with that. Now, what I'm gonna do here is I'm going to use this tool here. This is the perpendicular constraint. I'm going to select the lines that I want to have the perpendicular constraint, and I'm going to click that there. Now what this should do is you can see that those two lines are perpendicular. But what's going to happen is that I won't know if they're exactly, if this channel is in the middle, because I want to be able to drill direct into the pipe. But if I go like this, it'll be off center, and I don't want that. So I'm going to use the equality constraint again on these two here. Set those two to be equal. These two angled lines. And now, as you can see, this here is that little cutout is perfectly centered. These are at a perfect 90-degree angle to each other and a 45-degree angle from the vertical. So now I'm going to move on to, actually that, let me check here, just make sure that these are, the corner is actually connected. Perfect. Now I'm going to move on to adding dimensions. So one of the things that I like to do, what I just did there was I closed out of the sketch. So as you can see, I'm here. I'm in the sketch viewer. If I hit close, that closes out the sketch. But if I just go back here to the model, I can select, I can look at objects, I can hide objects with the space bar and show them again. But but I won't be able to do things in other workbenches per se, like create a spreadsheet, which is what we're going to do. So you can hit escape, you can click that close button in the tasks bar, or yeah, just hit escape, hit close, and then you're good. So let's move on to adding dimensions with the spreadsheet. So what I'm going to do, actually I'm going to name this one end profile. It helps keep things organized to, let's call this V guide. Perfect. Cool. So what I'm going to do is I'm going to now pull out my spreadsheet. So what this allows me to do, I'm going to call this parameters. So what this is going to let me do is this is going to let me create values. So I like to do something where I put the name on the left and then put the value on the right. So let's do height, width, and then we'll do channel width, drill, let's call this one hole size. Perfect. So I'm just kind of setting out some values here. Now, me personally, I like to design in millimeters, but FreeCAD automatically does your unit conversions for you. So I can put in, so I'm going to do this in, I'm going to do this project in both, just to make things a little bit funky so that we can really make FreeCAD stretch its legs. If you don't want to do that, that's fine. You can do it all in inches or all in millimeters. But my personal preference is for millimeters. So I'm going to make this about 20 millimeters by 20 millimeters, right? So 20 mm, 20 mm. That width may end up being redundant. Now, 20 mm, I'm gonna make the channel width, let's make that 5 millimeters. I'm gonna have the hole size, let's say it's a 1/2 inch drill bit. I'm gonna go 1/2 inch. Yeah, so, whoops, that's 1/2 inches, sorry. There you go, whoops. Is that right? Oh, I guess so. Okay. So that's a 1/2 inch. What? There we go. Perfect. So 1/2 inch, as you can see, automatically converts it to millimeters. You can actually set your where's it? Preferences. You can set your desired unit under preferences. You can see under units. So it's units, standard, millimeter, kilograms, seconds, degree. You can go to US customary or, you know, any other kinds of stuff. So, yeah, perfect. I prefer metric. That's just how I like to work because I find it feels more precise and I feel cool using it. But it's honestly up to you and who you're working with. So, just a quick thing that I have on my desk that's really kind of helped me with designing is just a cheap set of like $10, $20 calipers, like digital calipers from the Harbor Freight, from Amazon, like super cheap stuff. This set of calipers I use not for like precision. I've used to pull measurements though. But the main reason I design with a set of calipers next to me is so that I can kind of eyeball things. Because sometimes when you're building stuff in FreeCAD, you forget how big or how small things really are. And so if I say, hey, I want to be able to like turn a knob or interact with a part or kind of, I want something that's big but not too small, one of the things that I like to do is I like to pull out my pair of calipers, pull it out to say whatever the measurement I'm looking at is. So for this, it's 20 millimeters. And just kind of look at it and say, is this too big or too small? So that's how I got all these measurements here. Now what I'm going to do now is I'm going to add aliases. Now aliases are great because while I can refer to each of them by their cell, row, and column, I much prefer aliases because it's a lot easier to remember parameters.height over parameters B1, right? So I'm going to go up here into alias, and I'm going to write down height, and I'm going to hit enter. Now as you can see, this box is now yellow. That means that it has an alias assigned. If you don't like doing it this way, you can also right click on the box you want to edit or give an alias to, click properties, go over to alias, and then add your alias and hit OK. This one's going to be width. I'm just naming them as these kind of descriptors on the left, just so it's easier on me when I go to kind of reference this and say, hey, I want to build another addition to this part, and I want to reference these measurements, so I don't have to actually go in and see what the alias is. Whole size, perfect. So now all these have aliases. So I'm going to actually make these units affect things in my sketch, I'm going to go back and use my constraints. So what I did right there is I just opened up the sketch. And as you can see in this bottom row here, I've still got this parameter spreadsheet that I can flip back and forth between. So I'm going to start by adding a height. So here, these are these constraints. You've got your width, and we're going to go over to this one, the vertical distance. So as you can see, it already has a value. What I can do is I can select it. I could enter 20 manually, but then that won't change based on my spreadsheet. What I want to do is I want to hit equals, which pulls up the formula editor. Start typing the name of my spreadsheet. So parameters. So I can go down to it and hit enter. So parameters dot. I can also just type dot. This is kind of like object oriented, so parameters dot, and the thing that we wanted was height. So the result is 20 millimeters, and as you can see, that matches with the height that we have specified here. You'll also notice that it's automatically kind of added the measurement, or made this one the same height. Now, if you notice, it's actually come up off of the axis, which we don't want. So I'm just going to go ahead and give that bottom one a horizontal constraint. Make sure it stays down there. Okay. I'm going to add a horizontal distance here. I'm going to do the same, but I'm going to use width. Parameters dot width. Perfect. So you can see it's now like this. And now all we have to do is specify the channel width. So that is going to be in here. Boom. Another horizontal constraint equals parameters dot width. Oh, whoops, not width, sorry. It's going to be channel width. Perfect. So that's going to be 5 millimeters. Now, one of the things you can also do is if your drawing is getting a little bit cluttered, like that looks, I don't like the look of that. I can click on my constraint and I can drag it around. So you can see that I've kind of neatened everything up so that everything's kind of readable. But I have forgotten one of my one of the dimensions on here. You can still see that it's an under constrained sketch with 1 degree of freedom. Everything that's fully constrained is labeled in green. It's highlighted in green. Yeah, and you'll be able to identify parts that we haven't constrained yet. So what we're going to do here is we're going to add a channel depth. So I'm going to right click in here. I'm going to go insert rows. It's going to pop out a new row. Channel depth. So I like to keep things kind of organized around. So I'll put things that are related to the same thing together. For example, I have channel width and channel depth next to each other, height and width next to each other. And I'm just going to give this 2 millimeters. Perfect. I'm going to go back to my spreadsheet, or to my sketcher here. I'm going to give it a vertical distance, and I'm going to set that to be parameters.channel depth. Perfect. So, as you can see, we've now got the end profile of our V-drill guide here. It's not exactly the same, but that's all right. We can go ahead and we can go ahead and we can pad this out. So I've exited out of the sketch, and I'm going to select it in the currently active body, which is V-drill guide. I'm going to go up to the part design workbench here, part design. I'm going to select the sketch that I want to pad, and I'm going to click this here, which is pad a selected sketch. So I'm going to give this an arbitrary number 20. Now, I still need to also give this an actual entry in my parameters spreadsheet. So I'm going to do that right now. So I'm going to do guide. Oops. So I'm going to call this, let's just call this length. Length, and let's go 30 millimeters. Or let's do 20. So we're going to do channel length. Or, sorry, not channel length, just length. Perfect. So now I'm going to go back, I'm going to select pad. Now, this is actually an important lesson here. One of the things you can do is if you, I've forgotten to put in the right measurement, or I want to go back and change it. You can click here on the object, or on the operation that I've just performed, pad, and then I can edit the length. So I'm going to set the length, same thing. I'm going to hit equal sign. I'm going to do parameters dot length. Perfect. Let's see. I don't actually know what this length to is, second pad length. But that first length is what we're actually going to be working with. So now we've got the general profile of this going on here, but we have not added the hole for the drill to go into. So I have a 1/2 inch drill bit. That's actually huge. Let's do a 3/8 inch. No, let's do 1/4 inch. So quarter. Oops. So 0.25 inch. Perfect. So 635. So what I'm going to do now is I'm going to map a sketch. Or I'm going to build another sketch and map it to a face. So there are two ways to do this. You can create the sketch first and then map it to the face, or you can select the face and click the sketcher button. I'm going to do one of each for demonstration's sake. So the hardest way to do this is to make a new sketch. Doesn't matter which base plane you pick, so just pick whichever one. Close out of that sketch, and then you're going to select the face you would like to map it to. Actually, I would rename the sketch. Once you start working with a lot of sketches, and you don't have them renamed, you'll be like, oh, did I want to map sketch 01 or sketch 0300 or something, right? So I'm going to just go ahead and call this one hole pattern. Hole pattern. Now I'm going to click on the face that I want to map it to, which is this top face here. As you can see in our kind of image, they're going from this top face towards that V and into the dowel. So I'm going to go ahead and click this tool here. Now there are a couple of things. So it'll ask you for the sketch. I'm going to pick the one that I just made, hole pattern. I'm going to hit OK. It's going to give me a couple of options to attach the sketch. Most cases you're going to use flat face. I'm going to hit OK. And now nothing will have really happened, right? But when you click on the sketch, it's going to be on this top surface here, right? So that means that when you're drawing on the sketch here, so like a circle, right, it'll be on your sketch there. Now, I'm going to do the process again the way that I've found is the most efficient for me. So the way that I like that's most efficient is I just select the face I want to map it to and click the new sketch button here. It's going to automatically add the sketch and attach it to the face that we had just selected. So I'm going to close out of the sketcher and enter the sketch again just to reset my view. Now what I want to do is I want to have this circle somewhere in the middle here. And immediately I've kind of run into something that I don't quite like about this, about mapping sketches to faces. And sometimes it's just hard to see. So I'll either do my design work at an angle like this, and I do that by holding down the middle mouse button in empty space, the middle mouse and the right click button, and kind of dragging it around. Alternately, I can switch back to the tree view, or the view of all my items here, select the part that I'm working on and hit space, because I already kind of know what it looks like. Now what I'm going to do here is I'm going to use construction lines. So this here toggles the toolbar or geometry to or from construction mode. So I'm going to set it to construction mode. I'm going to do, well, actually I don't usually do that. I'll just use constraints, honestly. So I'll constrain this point to that point, and that's going to be this is going to be width, or parameters.width divided by 2. And let me just check. Just double double check that I have it right. So, if I'm right, that was not the right dimension. I'm going to set this to, because if it was, well, I'm actually going to do the other one with the correct dimension now. So, I'm going to set these two to horizontal. I'm going to do parameters, width, hit enter. Oh, whoops. Got to make sure to divide that by 2. Perfect. What I actually wanted was I wanted this to be parameters.length divided by 2. So it's going to be perfectly in the middle. So I'm going to go back. I'm going to go into the sketch here. I'm going to define the size of the circle. Now, there are 2 ways to do this, and these are very important not to mix up. There's radius and diameter. If we have a 1/4 inch drill bit, that's going to be measuring the diameter. I'm going to set that to be equal to parameters dot hole size. Perfect. Now, I'm just going to do some kind of cleanup to make this all look a little bit better. There we go. That looks way nicer. Now, you can see that we now have the sketch matched to the top. Now we want to just kind of punch it through. What I'm going to do is I'm going to go here and go to create a pocket. Now, as you can see, I've clicked it, and what it does is it makes a pocket. Now, I can punch this pocket all the way through. Usually when I'm doing just kind of like a through hole, I'll just go complete overkill on the units, right? So 100. But if we needed to say, like, know exactly how far we had to go, we could calculate that. But for applications like this, where I don't have to worry about punching through another side of the part, like if I was drilling a hole through here, I just go complete overkill, go for a big unit, 100, right? So now, as you can see, we've got our piece here. It's got the hole through the center, like in our reference image here, but we're missing a couple of pieces. Now, if you're going to be using this and handling it, it's going to have some kind of sharp edges. This is totally, it's totally fine to have. I personally don't particularly care, but if I want this to look nice, then it's a different thing. So, if we want to make this look nice, we've got a couple of things up here that help us. These 4 on the right here, we've got, so I'll start by putting a slight chamfer on this hole here, like they have in our reference image. So I'm going to select the edge. It's highlighted yellow here, and then I'll click, and it highlights green. So I'm going to click on this one here, and I'm going to chamfer it. I usually just do these manually. Sure, 1 millimeter chamfer looks fine to me. Hit OK. And then I'm going to do, let me look at my reference image again. So it's rounded off on all these vertical corners here. I'm going to round these off. I'm going to make this pretty beefy. I'm going to give this a 3 millimeter radius fillet. Perfect. Oh, and it looks like I've selected another edge. So to undo stuff, I can either hit Control-Z or I can delete the last added feature. So I'm going to go back and I am going to select all the edges again. So I'm going to select, hit Control, or hold down Control as I select each of these. Perfect. Now I've got all 4 of the edges, as you can see. I'm going to go ahead and fillet that again, give it a nice beefy fillet, 3 millimeters. Perfect. That looks beautiful. What I want to do here now is I want to round out this bottom edge here. Now, this is going to be an interesting opportunity to explore how FreeCAD handles filleting like weird edges like this. So, if I only fillet this edge, it's going to have like a weird transition between round and sharp corner, and it's not going to like that. So what I'm going to do here is I'm going to hit fillet, right? And it's going to actually fillet the entire connected edge. This is just something you have to keep in mind when you're filleting stuff. So I'm going to add another edge in here, not that edge. So these are both going to round off. And that's going to be, so yeah, both of those are going to round off. And then what we can do now is, now that I'm satisfied with my results here, I'm going to go File, Export, and I'm going to export this to my 3D printing file. I'm going to call this V-Drill Guide, and I'm going to output this as an STL mesh. I'm going to hit Save. Okay, and then I'm going to see you in a bit in Cura, where I'm going to show you how to orient this for printing. In designing my CAD file, I kept Cura in mind. So what we're going to do is we're going to open up our V-Drill Guide. It's going to be placed on in the center of our slicer here. So, immediately I see some issues. First off, we've got this weird overhang here. 3D printers are really bad at printing overhangs. Cura will actually tell you, hey, I'm going to have issues with this. As you can see, you've got this red here, which shows that it's going to have issues. So what I'm going to have to do is I'm going to have to reorient my model to be flat like this. Now, you're going to say, David, isn't there this chamfered surface under here? I'm going to say, yeah, that's fine. Small overhangs like this are good, but huge overhangs like this hole here, or even this V area here, would not be great. So now that I have it oriented, this would be appropriate to slice and send to the printer.